Okay, thank you, sir.
నువ్వు అన్మ్యూట్ చెయ్యి.
సరే, ఇప్పుడు మాట్లాడారా మీరు? చెప్పండి సార్. వినిపించట్లేదు సార్. మరి స్టూడెంట్స్ వెయిట్ చేయండి అమ్మా, సార్ మళ్ళీ జాయిన్ అవుతున్నారు. డోంట్ లీవ్ ద క్లాస్.
What is 7?
హలో
Hello, madam. Am I audible now?
ఇప్పుడు వాయిస్ వినిపిస్తుంది సార్ క్లియర్గా.
Now,
ఓకే సార్.
appear also. What about the screen?
ప్రెజెంట్ చేస్తున్నారా సార్?
Madam. Yes, madam. Screen కనిపిస్తుందా?
ఇంకా కనిపించలేదు సార్.
కనిపించలేదా? Present already connected it is. Okay, let me. What about now, madam?
ఒక్క నిమిషం ఉంచగా. ఓకే సార్.
Okay, linear algebra is.
ఓకే సార్.
Okay, right. Let me start. Good evening to all of you.
గుడ్ ఈవినింగ్ సార్.
Good evening.
మా స్టూడెంట్స్ రెస్పాండ్ అవ్వండి అమ్మా.
Okay, this is my second session. A brief review what we have discussed in my previous session. I started linear algebra, in it matrix algebra. I started with the basics of the subject. First, matrix means any rectangular array. Rectangular array, you have rows and columns. And here order means the number of rows cross the number of columns. Here A23, A32, identification of elements in a matrix. Next, types of matrices. Row matrix, or we call row vector, means it contains only one row. Column matrix means it contains only one column. Horizontal matrix means you have less number of rows compared to columns. Vertical matrix means you have more number of rows compared to columns. Square matrix means number of rows and number of columns are equal. Then a square matrix of order n cross n, we simply say order n. Whenever you have a square matrix, you have diagonals. You have two diagonals. In particular, from A11 to ANN, this is called principal diagonal. The sum of these elements is called trace of the matrix. Trace is defined only for square matrices. Next, it depends on elements, we classify the matrices. This is a triangular matrix, in particular lower triangular matrix. This is upper triangular matrix. Any one of these we call triangular matrix. Now this is a diagonal matrix. It is both lower and upper triangular matrix. If the diagonal element remains same, we call it as scalar matrix. If this scalar is 1, we call unit matrix. If this 1 also becomes 0, we call zero matrix. Here 1 to 5, 1 to 4, these 4 are square matrices. Means never say a rectangular matrix is triangular or diagonal or scalar or unit matrix. These should be square matrices. Whereas null or zero matrix, it can be square or rectangular matrix. This is the classification depending upon the elements. Next, depends on operations. Operation. For example, transpose is an operation of a matrix. A is the input, A transpose is output. Suppose A is this one, 1, 2, 3, first row, second row, 4, 5, 6. Then A transpose is this 1, 2, 3 comes as first column here, next 4, 5, 6, second column. This is A transpose. Input and output. A matrix is said to be symmetric if A transpose equal to A. A transpose equal to A. Automatically, never say a rectangular matrix is symmetric. It should be square matrix. All square matrices are not symmetric. Those square matrices whose transform is itself. Next, if A transpose is minus A, we call skew symmetric matrix. If A transpose equal to A inverse, we call orthogonal matrix. That can be written A into A transpose I equal A transpose into A. Next, another operation, conjugate. If A is the input, then A bar is the output, we call conjugate. Suppose an example, if A is this one, A bar is this, you just replace I with minus I. Here I stands for root of minus 1. Suppose A is 1 minus 2, 4, 3, then A bar remains same because there is no I term here. To replace I with minus I, there is no I term. Means if you have only real entries, the bar is itself. Or A is a real matrix means if and only if A bar equal to A. If A is real, A bar should equal to A. Suppose A bar equal to A, definitely A is real. Next, another operation. Conjugate transpose. We denote with A power theta. Conjugate another transpose. For example, A is this one. I calculate the same matrix I have taken. Its conjugate is this one. Then transpose. We denote with A power theta. Or you can take transpose and then conjugate. It remains same. Next. Using this operation, we classify the matrices. If A power theta equal to A, we call Hermitian matrix. A power theta equal to A, Hermitian matrix. A power theta equal to minus A, skew Hermitian matrix. In a Hermitian matrix, the diagonal elements are real. In a skew Hermitian matrix, the diagonal elements are pure imaginary, I times, or 0, I times 0 is 0. Next, A power theta equal to A inverse. A power theta equal to A Hermitian matrix. A power theta equal to minus A skew Hermitian matrix. A power theta equal to A inverse we call unitary matrix. Unitary matrix. Previously, A transpose is A symmetric. A transpose is minus A skew symmetric. A transpose equal to A inverse orthogonal. The same here. Hermitian, skew Hermitian, unitary. It is not unit, unitary matrix. A power theta equal to A inverse. It is same as A into A power theta equal to I equal to A power theta. Now, suppose A into A power theta into A are same. The result need not be I. If these two are same, we call the matrix normal matrix. Normal matrix. Every unitary matrix is definitely normal because the result is also I. But normal need not be unitary because the result need not be I. Next, if A square equal to I, we call A is involutory matrix. If A is square equal to A, we call A idempotent matrix. Next, if A power k plus 1 equal to A, we call A is periodic matrix. The least positive value of k is called period. If A power k equal to 0 matrix, then A is called nilpotent matrix. The least positive value of k is called index. Next, every real symmetric is Hermitian matrix. Every real skew symmetric is skew Hermitian. Real orthogonal is unitary. If A is Hermitian, I into A is skew Hermitian. The next, I explain the determinants of second order. AD minus BC is called determinant of this one. Why we call determinant? I already explained in my previous session. Similarly, third order determinant. Using first row expressed, using second column I expressed. In fact, to find determinant, you can use any row or any column. Next, similarly, fourth order determinant. To calculate fourth order determinant, we express it as 4 third order determinants. Each third order determinant we express as 3 second order determinants. The second order determinant contains two terms, AD and BC, two terms. Automatically, the fourth order determinant contains 4 times into 3 into 2, means factorial 4 terms. Similarly, suppose an nth order matrix given to you, its determinant contains factorial n terms. Next, minor. Minor means it is determinant of submatrix, square submatrices. Determinant is defined only for square matrices. Minors are determinants of submatrices. Cofactors means minus together with the sign, minus 1 for I plus j. If you write all the cofactors in place of the elements of A, it is called cofactor matrix. If you write its transpose of cofactor matrix, it is like this. We call it as adjoint of A. Then, if A, the given matrix A, you can calculate adjoint A. A into adjoint A gives det A into I. Det A into I. Automatically, A inverse is adjoint A by det A. Next, A matrix is said to be singular if determinant is 0. Non-singular means determinant not equal to 0. Next, determinant properties. Det A equal det A transpose. And if you interchange any two rows or columns, we put minus sign. If you get two same lines, parallel lines, both rows are equal or both columns are equal, determinant is 0. If a row or column is multiples of k, you can take k common. From any row or column, you can take k common like this. Next, if a row or column is addition of two numbers like this, you can express it as sum of two determinants. Next, any column or row can be written as, can be replaced as that plus constant times the next plus constant times the next. You can replace here first column I replaced with k times second column plus L times third column. Usually we select k value, L value we ignore. Means L value is in usually. The determinant remains same, please. Please observe we are replacing the first column. Its coefficient is 1. Next. Okay. Observe this. Det AB is det AB is det A into det B. Because det A is a number, det B is a number. Therefore, 2 into 3 is 3 into 2 type. Therefore, this can be written as determinant of BA, which is det B into det A, because these two are numbers. Now, det AB, det B are equal. AB and BA need not equal, but their determinants remain same. Next, det of K is a scalar now, not a matrix. K power n into det A, where A is nth order matrix. The reason, from each row we take k common. Therefore, from first row 1k, second row another k, and so on. From nth row another k power n you get. Don't write k into det, k power n into det. Next, yesterday I have not explained this. What is determinant of adjoint A? Determinant of adjoint of the matrix. Observe it. We know that A into adjoint A is adjoint A into A is det A into IM. This we know. From it you got A inverse is adjoint A by det A. Now I need determinant of adjoint A. So I am taking this, you can look like this. This is A and adjoint A transpose of cofactors matrix A into adjoint A. Of course, it is same as adjoint A into A. That is det A into I means it is a scalar matrix. Det A into I. All the entries of I multiply with the scalar det. It looks like. Now I need determinant of adjoint A. So take determinant both sides. Determinant of this one is determinant of this one. Determinant of left side. Determinant of left side is determinant of right side. Right side determinant, from each row you can take common, det A common, det A whole cube you will get. Into determinant of I is 1. Determinant of I is 1. Therefore, right side det A power n if A is of order n. Now the left side A into adjoint A, determinant of this can be written as det A into determinant of adjoint A. Det A into determinant of adjoint A. Left side can be written because det of AB is det A into det. Therefore, determinant of adjoint A is det A power n by det A. Because these are numbers. Det A power n by det A is det A power n minus 1. Therefore, determinant of adjoint A is det A power n minus 1, where det A not equal to 0. I explain why this is from this. Next. Determinant of A inverse. It is det A whole inverse. This you can use only when determinant not equal to 0. Determinant of A inverse is det A inverse. Now observe. I want to give the proof of this one. Determinant of A into A inverse is determinant of I, because A into A inverse is I. Now left side can be written as det A into det A inverse. Det A into det A inverse is det I is 1. Determinant of unit matrix is 1. So, what is determinant of A inverse? 1 by det A. 1 by det A means det A power minus 1. 1 by determinant of A inverse is 1 by det A. Here, please observe this A inverse means inverse of the matrix. It is det A power minus 1 means 1 by det A. Det A is a number. Later. Yesterday I explained this. Equality of two matrices. The corresponding entries are equal. Addition of matrices. The corresponding elements we add. Subtraction. A minus B. The corresponding elements we subtract. Scalar multiplication. All the entries of A we multiply with next multiplication. Okay, A equal this one, B equal this one. A plus B. We add the corresponding entries. A minus B. 2 into A. All the entries multiply with. Now observe A into B. Please, all of you. I have written this one. Okay, any one of you, please? Please respond. A plus B. Does it right or wrong, please? A plus B. Right or wrong? Please.
Right, sir.
A plus B, right. Very good. What about A minus B?
Right, sir.
Right. 2A?
Right, sir.
Right. A into B?
Wrong, sir.
Wrong. Okay. Why this is wrong? Yesterday I asked you the question. In my previous session I asked you the question. Here, when you are adding 2 plus 1, 3. 2 minus 1, 1. 2 into 2, 4. Similarly, 2 into 1, 5 into minus 2, minus 10. Minus 6 into 4, minus 24. 3 into 3, 9. I have written like this. You are telling it is wrong. Why this is wrong? What is the correct answer here? Anyone, please? What is the first element? You are telling
22, sir.
Huh? It is?
22.
Right, very good. Because 2 into 1 plus 5 into 4 row column. Why 22? But I have written 2. But my question is why it is wrong. Okay. Addition, the same way of addition, subtraction, I did it. Okay. I'm going to explain why this is wrong today. Now, whatever we are doing, we should have application. I am doing A plus B, A minus B, 2A, but AB not like this. Why not like this? I don't have application initially. Okay, of course, this has another applications later. Initially, we don't have any applications. Whatever we are defining, it should help us in calculations. Okay, let me explain why. Observe this. I have taken a picture on a rubber sheet, an elastic sheet. Does this nice picture? Anyone of you, please? Does it look nice? Does it look nice or not? Please. Rajesh picture బాగుందా లేదా? Anyone of you? Please. I don't feel.
No, sir.
No, it's not good. Okay, very good. So, I have drawn an elastic sheet. I stretched the sheet to get this one. Okay. Does it look nice?
Yes, sir.
Yes, sir.
Yes, sir.
Very good, very good. Next, I stretched further the sheet. I got another transformation. Does it look nice?
Yes, sir.
Which one
Yes,
is
sir.
better among these three?
Third one.
Third
Third
one. Why? Third one. Everybody says the third one is a good picture. Why you are telling third one is picture good? Why not the first? I am asking the definition of beautiness. Okay. Why third one? Everybody likes third. Why not first? Somebody likes, of course, second. Third is compared to better compared to second also. Why? Can you define beautiness? I'm explaining through mathematics. Okay. Anyone can tell? Why you are liking third? Why not first?
Perfect shape.
Perfect shape. Very good. How do you define perfect shape? Because we know perfect shape from our senses, but the system should know it. The computer should know it.
Symmetrical.
Very good, very good. The correct word, symmetry. Very good, very good. Now, coming to this one. For example, the second picture, when you fold along vertical in middle, the overlapping remains same. Similarly, horizontal fold also remains same. But in the third figure, you can fold along any diagonal, it remains same. The second figure, you have two axes of symmetry, x-axis, y-axis. Whereas the third figure, you have infinite diameters along any axis. Axis means here any diameter, you can fold, it remains same. That's why you have many symmetries, that's why it looks nice. Whereas the first figure, it doesn't have symmetric lines. That's why it's not. Okay. Now coming to general view, for example, you have a ear. Ear. Another side, you don't have ear. How you look? Observe it. One side you have earring, of course. One side you have earring, another side you don't have earring. How you look? It is not good to us. If both sides, if you wear the same size ring, it looks nice because of the symmetry. So, to get good picture, we require symmetry. Okay. Now coming to the present topic. Now, here I have drawn three pictures. The first one is the input. I require the output the last. Input is the first one, output is the last. How do you get it? It's a transformation. We are transforming here to here by writing on a rubber sheet. We are stretching that rubber. How you are stretching to get this picture? Later again you stretch the picture to get this. Let me explain. It is a 2D figure, therefore I am taking x-axis, y-axis to describe this. The first one, it is instead of x comma y, x, y, I am taking x1, x2, x1, x2 system. It is y1, y2, this is z1, z2, x1, x2, y1, y2, z1, z2. Okay. To describe all the points of this figure, after stretching, it becomes like this. After stretching, again it becomes like this. I am taking one point to describe. For example, I have taken a point here. It is a rubber sheet. I stretched it to get this picture. Then this point has come here. This point has come here. Again, I stretched it. This point has come here. The original point is here. Has come. Similarly, all the other points you can observe like this. Okay. Now, this point, how you are getting to here, how you are stretching, that is important. Means this point you can identify with the horizontal x1, the vertical x2. This is x1 distance, height x2. Here, this is y1, the height y2. This y1, y2, this y1 depends on the given inputs x1, x2. y1 depends on x1, x2. Similarly, y2 also depends upon x1, x2. Observe how you are stretching horizontal. For example, this y1 is ax1 plus bx2. Please observe. A and B I selected. For example, a value 1, b value 1. Then y1 equal to x1 plus x2. For example, x1 is 3, x2 is 2. Then a, b are 1s. Then y1 is 5. Means this 3 become 5. I stretched it horizontally 5 up to 5. Okay. Here a comma b are constants. I assumed a, b are constants because it's linear stretch. There are no x1 square, x2 squares. So we are not twisting it. We are just simply stretching. Linearly straight we are stretching. Similarly, the y2 depends upon x1, x2. Vertical stretch. cx1 plus dx2. y1 depends on x1, x2 like this. y2 depends on x1, x2. Therefore, this ABCD values tells us how you are stretching. Means this ABCD tells us the transformation from this picture to this picture. Okay. Similarly, now Again, you stretch this figure to get the third figure. Therefore, now Z1 depends on Y1, Y2. Z2 depends on Y1, Y2. Z1, ABCD already over EY1 plus F. EY1 plus F. Z2 similarly, EFGY1 plus F. Z2 depends on Y1, Y2. These are the mathematical equations. Any given point, X1, X2 becomes Y1, Y2 with the transformation ABCD. ABCD is transformation. ABCD values tells us how you are stretching. Similarly, here Y1, Y2 input, Z1, Z2 output. This EFGH tells us how you are stretching to get this picture from this picture. But of course, we require directly the output from the input. Means I require Z1, Z2 directly from X1, X2. So what we do? This Y1, Y2, we substitute here. Y1, Y2, I require Z1, Z2 directly from the input X1, X2. So Z1 equal to E into Y1 is nothing but AX1 plus BX2. I substitute this. Z1 equal E into Y1 plus F into Y2. So if you multiply this one, EA X1, EB X2 plus FC X1 plus FD X2. Now taking X1 common, what do you get? If you take X1 common, please tell me. Please tell me this. Please.
EA plus FC.
EA plus FC into X1.
One.
Next, EB plus FD into X2. Right. Similarly, Z2 equal G into Y1 is this, H into Y2 is this. Now tell me this, please. Please.
GA plus HC into X1.
Right. GA plus HC into X1. Next.
Plus GB plus HD into X2.
Right. Very good. What's your name?
Rukmini, sir.
Rukmini. Very good. Very good. Please interact. Okay. Now come to this one. Finally, I got Z1, Z2 from X1, X2 like this. Okay. Now, if you observe this, if it is in three-dimensional, I need X1, X2, X3, Y1, Y2, Y3, Z1, Z2, Z3. Not only horizontal, vertical stretch, also the other side also the stretch should be. The calculation becomes further difficult. Now I need the shorthand long ways to this calculation. Shorthand means here matrices. Matrices is a shorthand long ways. Initially I explained timetable, Monday first period, Monday second period, Monday third period. We don't write repetition of Monday again and again. Simply a row. Similarly, Monday first, Monday, Tuesday first, Thursday, Wednesday first. We don't write first again. Repetition we try to avoid. So now I want to apply the matrices to this calculation part. Nowhere I used matrices now. Now coming to this one. This Y1, Y2. This I am writing like this. Y1, Y2 equal to Y1, Y2 I have written on one chip. You can think like see. AX1 plus BX2, CX1 plus DX. Why should I write X1, X2 twice? I want to write only once. To give this information, I need just 6 symbols A, B, C, D, X1, X2. Okay, so to give this information, I am writing A, B, C, of course. First, I reduce to equality symbol. These two equations I have written single equality first. I have written single equality. So these two I have written on one chip. These two written on another chip. These are connected, and I have given instruction. I have given instruction to my machine that if two chips are equal, if the corresponding places are equal, the corresponding places are connected. Two chips are equal if the corresponding places are equal. That is the equality of matrices definition. Okay. Now the right side, I don't want to write this X1, X2 twice. Just like Monday, Monday first period, Tuesday first period. I don't want to write repetition. To represent this one, I need 6 symbols. This I am writing as ABCD, and then this x1, x2 as a column I am writing. These two are equal. I define. I don't want to write x1, x2 again and again. Therefore, I have written only once. To give this information, I need 6 symbols: A, B, C, D, and x1, x2. Okay. You can observe these two are, when you write these two chips side by side, the output should be this. Please. The output should be this. I have given instruction to my machine. AX1 plus BX2, the output. CX1 plus DX2 is the output. When you write these two side by side, the output should be this. Should be this. Means row column wise, I have given output. That is instruction to my machine. Okay. Similarly, coming to this transformation, Y to Z's. Of course, this further you can write simply this Y1, Y2, this Y terms. Y1, Y2, I denoted simply Y. When I press Y, it should recollect Y1, Y2. When I press A, it should recollect this transformation, ABCD. When I press X, it should recollect X1, X2. Therefore, this I am denoting with Y. This is A, X. When I press Y, immediately it recollects Y1, Y2. When I press A, it recollects ABCD. When I press X, it recollects X1. Finally, I call simply these two entire equations simply I am writing as Y equal to AX. Y is the output, X is the input. Of course, matrices. Here, X is the input. X is the column vector input. Y is the column vector output. Whereas A is the transformation matrix, because this ABCD tells how you are stretching. Okay, Y equal to AX is the transformation. We call linear transformation. Similarly, Z equal to, you can write BY. Z equal to BY. Okay. Therefore, now my calculation. Observe. The first one is Y equal to AX. The second one is Z equal to BY. Now, I require directly Z terms from the input X terms. So, you just replace Y with AX. Means cut Y, paste AX, because these two are equal. These two chips are equal. Cut Y, paste AX. Observe how I am doing. You just cut Y, paste AX. Okay. Z equal to BAX. Okay. Now, what is this BA? What is this BA? Now tell me what is B here. What is B? Please tell me, any one of you. Here the transformation matrix B. Please, Yogi.
Yes, sir.
What is B here? B. Please tell me what is B here. Here, A is ABCD, transformation. Now here to here, what is the transformation? Z equal to BY. Z equal to BY. What is B? Okay, please concentrate. It's easy. Here A is ABCD, very clear. What is B? Rukmini?
BCD, sir.
EFGH.
EFGH, very good. EFGH. Here A is the transformation, ABCD. Here EFGH is the transformation. This is Z equal to BY. EFGH. B is EFGH. Okay. Into A, not into A, side by side, of course. You can think like it. What is A now? ABC. Okay. Now this BA is EFGH ABC. Now please observe, I need Z value directly from X. This is the BA. Now this BA, when you write this B and then A side by side, the output should be these four. Please observe this here. Because Z1, Z2, Z terms, column vector. X is X1, X2 here. So the BA should be what, please? Please tell me here. From the equations. We don't know any multiplications, please. This PA should be these four. Do you agree?
Sir.
Okay. This BA should be these four. Okay. So you will get EA plus F. I am copying just these four, please. These four, I am just copying. Okay. These four I just copied. Now observe BA. When you write these two side by side, the output should be this. Otherwise, my calculation is wrong. It is not EA, FP, GC, HD. It is these four elements. Otherwise, calculation is wrong. So, if you define matrices multiplication, means writing matrices side by side, the output should be row column. Row column. Here also row column. Please observe. 2 cross 2, 2 cross 1. Row column here also. That's why when you write matrices side by side, we call matrix multiplication, and the output is row column wise. If you define EA, FP, GC, HD like it won't help us in equations. Once if you define row column wise, in calculation y equal to x, z equal to b, just cut and paste. Cut y, paste ax. Very simple. Therefore, this entire calculation become just these three steps: y equal to x, z equal to b, z equal to bax. Of course, we give the instruction to the machine. Side by side matrices means row column wise, means matrix multiplication. I think you got why we are defining matrix multiplication row column wise. Okay. Next. Okay, multiplication. Now I am defining formally what is multiplication of matrices. Let A equal to Aij M cross N. P equal to Bij N cross P. Please observe, these two need not be square matrices. It is M cross N, but it should cross with it should start with N cross P. Yet these N and N should be same. Then only you can define A into P. Then A into P is a new matrix C. The entries of C are Cij. A into B is a new matrix C. The entries of C are Cij. And the order of the C means the product is M cross P. M cross P. Okay. Now, I need the Cij from the entries of A and B. Means I need Cij from this Aij and Bij's. What is Cij now? Where Cij equal to dash. 4 answers may be given. 2 matrices given to you, you can easily multiply it because you know row column wise will multiply. But here I am asking the notation. What is Cij? Please tell me, any one of you, please. 4 options may be given. May be given as a bit to you. What is Cij now? Tell me, any one of you. What is Cij here? I am simply asking the definition of matrices multiplication in notation. Because when you write matrices side by side, the output should be row column wise. To write row column wise, the notation you require to write a program. What is Cij now? Tell me. Anyone, please? That's why I'm explaining the basics, please. Just the matrix multiplication in notation I am asking. Because you need notations. That is more important to you, not just writing multiplication of 2 matrices. Okay? Shall I explain? No, observe. Okay. If you don't know, I will explain. You need not worry about it. I'll explain from the basics. That's why please listen carefully why I am explaining from the basics. You need it. Now, Cij, 4 options may be given. You can easily remember like this because from known to unknown, I want to explain. You know row column wise. The Cij is obtained by multiplying which row of A with which column of B? Can anyone answer at least now? Cij is obtained from which row of A? First row or
First
second?
row.
First row? See, Ij I am asking. Ith row, followed. Not first, second, third. See, Ij means here I row. Ith row of A. Multiply with which column?
J column.
Very good.
Eighth column.
Ith row of A multiply with jth column. Then you will get Cij. That concept you know it now. Now, what is first row here? A1j. I value should be 1. First row means A1j, A2j, A3j, A4j. Do you agree? That's it first row. First row or not?
First column.
Right, very good, very good. Actually, I want to verify whether you are listening or not. Very good, very good. You are right. That is first column, not first row, please. Now tell me first row then. What is first row?
A1J, A1,
A1, J. Very good. Next,
A1J,
A1, J. First row, entire row I am asking. First row A11, A12, A13, A14 and so on. Got it? A11, 12, 13, 14. J is vary. Therefore, the first row is A1J. J is vary. Got it? Second row A2J. Third row A3J. Now observe. I am writing ith row. Ith row AI1, AI2, AI3. Please observe ith row AI1, AI2 and so on AIN. Got this? Please. Ith row. First row 1, 1, 1, 2, 1, 3. 1N. Ith row I1, I2 and so on IN. Because it's nth column. First column, second column, nth column. Okay. It is ith row of A. Now tell me jth column of B, please. Tell me jth column of B. Tell me jth. What is first column of B then? Column. B11, B21, B31, B41 and so on like this. The first column is J value is 1. Followed. First column. Second column. Third column. Now tell me what is jth column? J remains same. I is varying, please. Now tell me jth column. Any one of you, please. What is jth column?
B1J, B2J,
B1J, very good.
B2J, B3J,
Very good. And so on. What is the last term? Please tell me.
BIJ,
B last. 1J, 2J, 3J.
IJ,
BMJ. NJ.
NJ, very good. NJ.
BNJ.
Very good. NJ. Okay, NJ. You have N rows. First row, second row, third row, N rows. N rows. Jth column it is. I think you got it. Ith row. Each contain I. Ith row. Jth column. J. But 1 to N. N cross. Okay. N rows. You have N rows. Here you have N columns. Here N rows. Now, ith row we are multiplying with jth column. Now, AI1 into B1J plus AI2 into B2J and so on. AIN into BNJ. You have N elements. Here also N elements. Got it? Row column wise. AI1 into B1J plus AI2 into B2J and so on. The last are AIN into BNJ. I think you got it now. Okay. AI1, B1J, AI2, B2J and so on. AIN, BNJ. Okay. Now, anyone, please, can you write in sigma notation, short notation. I prefer short notation. You got CIJ, you got answer. CIJ is the answer. You got the answer. Now tell me what is short notation for it. Using sigma notation. Plus, plus, plus is there. Anyone please? What is varying here?
Sigma AIB I runs from 1 to n
Very good.
plus sigma ABJ J runs from 1 to n.
Not that, please.
Sigma equal to 1 to n AI BJ.
AI?
BJ.
The sigma runs for what?
1 to n.
1 to n. Therefore, this 1, 2, 3, you should give variable, okay? Ij, Aik, Bkj. K is 1, K2, Kn. Got the point now? Suppose Aik, Bkj. K value 1, K value 2, K value n. The summation runs over K values. Got the point? Therefore, sigma K equal to 1, Aik, Bkj. This I and J are fixed throughout. I and J are fixed. K values vary. When K equal to 1, first term. K equal to second term. And so on. K equal to n. Got the point now? So, Cij is sigma Aik Bkj K equal to 1. This is the notation which you require matrix multiplication. You may be given 4 options like this, please. I think you never forget about now. Because you know the concept ith row multiply with jth column. It is about matrix multiplication in notation. You need notation. I think you realized why I am explaining the basics to you. Also, you will realize from the previous gate bits, some are some very basics. Okay, next. I define matrix multiplication. Now, the properties of matrices. Previously, I have given the properties of determinant. Now, properties of matrices. Commutative. Commute means we just travel A to B or B to A. A plus B equal to B plus A. Is right. Therefore, matrices addition follow commutative law. But AB and BA need not equal. Of course, sometimes they may equal. So, matrix multiplication is not commutative. Matrix addition is commutative, but matrix multiplication is not commutative. The next one, associative. Association means associate together. These two together with C. A and B together with C. It is same as A with B and C together here. Means association means just shifting brackets. The places remain same, shifting brackets is associative law. Matrices addition follow associative law. What about matrix multiplication? Does it associate or not? Matrix multiplication, please. Matrices multiplication associative or not? Please tell me.
Not.
Not associative, sir.
Not associative.
Associative, sir.
Associative it is. You can multiply the places. Please, AB and BA differs, but the order remains same. A, B, C. Just shifting brackets. It is right. You can verify using definition, of course. Matrices addition follow associative law. Matrices multiplication also follow associative law. Means when you are given 3 matrices, first multiply these two, then multiply with this. It is same as first multiply BC, then A with BC. It remains same. Okay, associative. Next, distributive. Means we are distributing A into B plus C. A is distributing within this house. At B, also at C. AB plus A. It is also right. In particular, we call it is left distributive. Into is distributed over addition. AB, yes. Similarly, it is right distributed. A plus B into C. AC plus BC. Therefore, both left distributive and right distributive are correct. Next. Okay. Now, in matrices, I explained addition, subtraction, scalar multiplication. All the entries multiply with a number k. Next, matrices multiplication also I explained. We have 4 basic operations in numbers: plus, minus, into, divided by. Those are the 4 operations. Coming to matrices, a plus b, a minus b, a into b, a by b. Do you know it? A by b? Any one of you, please? A by b. You know numbers 2 plus 3, 2 minus 3, 2 into 3, 2 by 3.
A into B inverse.
A into b. A by b. I am asking A by b simply.
Sir, A into B inverse.
No. I am asking A by. Have you ever seen A by b in textbook or somewhere? Have you ever seen? A plus b you have seen. A minus b you have seen. A into b you have seen. A by b have you ever seen in any textbook? చూసారా అక్కడనా? చూసారా లేదా?
No, sir.
No, right. Very good. You never faced A by B. Why you never faced A by B? You should know the reason. In numbers, you know the 4. In maths also, you should know the 4. Why it is not there? Do you know the reason? Anyone knows the reason? Don't you get this doubt? Okay, let me explain why A by B notation is not there in matrices. You should know it. Please. 6 by 3. What the value of 6 by 3? 6 by 3 value, please.
2.
2. Very good. Can I write this as 1 by 3 into 6? Can I write?
Yes, sir.
Yes,
Can I write it as 6 into 1 by 3?
Yes, sir.
Right, Shada? Both are right. Okay, right. Now, suppose both are equal because A into B is B into A in numbers. The same here, X, Y are numbers, please. X and Y are numbers. X and Y are numbers. I think you got it. 1 by 3 can be written as 3 power minus 1. 3 power minus 1. Similarly, 1 by 3, 3 power minus 1. Now, the same if you write in matrices, please. A by B. One of you explain me A B inverse. A by B. This 1 by B I have written right side. B power minus 1. Left side B inverse. Now coming to this one, B inverse A. It looks as some CA. It looks as AC. A into C. Are they equal? Are they equal? Please tell me.
No, sir.
Right, very good. They are not equal because AC and CA are not equal. We know AB and BA need not equal. We don't know it. But in numbers, definitely equal. I think you got the point. So, in numbers, you don't have any problem. 6 by 3. This 1 by 3 can send left or right. No problem to us. In matrices A by B, when you send 1 by B left, it gives one meaning. 1 by B, when you send right, it gives another meaning. They are differs. So, when you write A by B, which one you have to take? There is a dilemma. Whatever we are writing, it should give unique meaning in mathematics subject. There should not be any dilemma. So, if you write A by B, which one? There is a dilemma. That's why never use A by B notation in matrices. That's why we have never faced A by B notation in any test. Okay? Because if somebody asks you why A by B notation is not there in matrices, because lack of commutative property in matrices, we are unable to use A by B notation. Lack of commutativeness, we don't have commutative property. That's why we are unable to use the notation A by B. Okay. Next. Now come to this one. AQ. AQ You know A cube. A square into A. A into A square. Which one is right? Please tell me among these two. Because suppose a matrix given, A square you know how to calculate, row column wise multiplication. After getting A square, it looks as a new matrix B. Then it is AB, this is BA. Which one is right among these two, please? Any one of you? When you are I think your teachers finished the first unit and second unit also, I think they finished it. When you are verifying Cayley-Hamilton theorem, you calculate A square, A cube. When you are calculating A cube, after calculating A square, do you write A square into A or A into A square? Which one?
A square
into
into
A
A.
square.
Huh? A into A square or A square into A? Please, don't hesitate to answer me, please.
A square into A, sir.
A square into A. A into A square, is it wrong? A square into A, okay, very good. I agree with you. A into A square, does it wrong or right?
Right.
Right, huh? Okay, right. Please. It is also right. ఇక్కడే పెద్ద డౌట్ వస్తుంది ఎందుకంటే ఏబి పిఏ రెండు ఈక్వల్ కాదు కదా అనుకుంటారు. ఏబి పిఏ ఇన్ ది జనరల్ నాట్ ఈక్వల్, బట్ ఏబి బిఏ ఆర్ ఈక్వల్ అండ్ బి is A square. Why these are equal? Please observe. It is same as AAA. A square is AA. And this A square is AA. Please, I think got this point. Now it is shifting brackets. Shifting brackets, associative properties there with respect to multiplication. Got the point? Okay. AA, replace B and C with S, B and C with S, bracket shifting. Therefore, these two are always equal. Therefore, when you are calculating A cube, you can write A square into A or A into A square, you will get the same answer. You won't get two different answers like this because we have associative property with respect to multiplication. That's why these two give same answer. If they give different answer, you should not use A cube notation, please. Got my point? If you don't have associative property like this, perhaps we should not use the notation A cube. I think got the meaning. Because of associative property, we are able to use the notation. It gives unique meaning. Okay? Are you following or not?
Yes,
Yes,
sir.
sir.
A cube, A power 4, powers of a matrix we can use because of associative property. A by B notation we are not using because lack of commutativeness. Okay. Next. The next one. Transpose, conjugate, conjugate transpose, inverse. These words already explained to you. These are the operations. Any given matrix A, you are getting A transpose. A conjugate, replace I with minus I. Conjugate and then transpose. This is inverse of a matrix, adjoint A by det. Now, I am giving 16 properties at a time using matrix. To explain 16 properties, those 16 properties I am explaining through the shorthand notation matrix again, means the tabular form, so that you can easily remember it, please. 1, 2, 3, 4. Okay, transpose properties, conjugate transpose properties, inverse properties. The first one. The first one in all these, repeated operation. Transpose of transpose is A. Take any matrix, transpose and then transpose is A. Repeated operation. Similarly, conjugate of conjugate is A because replace I with minus I and then I with minus I, you get same. Here, rows with columns. Again, rows with columns. 2 times, you get next conjugate transpose. Applying both, you will get A only again. Conjugate transpose of conjugate transpose is A only. Similarly, A inverse is adjoint A by det. A inverse of inverse is A. I think you got this. Repetition. transpose, conjugate, conjugate transpose, inverse. Okay. The second one, K into A, scalar multiplication. K into A transpose. K is a number now. All the entries of A multiply with K, then take transpose. It is same as first transpose, then multiply all the entries with K. It remains same. Don't write K transpose. That K is a number. Similarly, what is K a whole bar? K bar, A bar. Conjugate. Conjugate of Ka is conjugate of the number K into conjugate of the. Please, K can be 2 plus 3i. Then K bar is 2 minus 3i, please. K bar. Conjugate of a number. It is conjugate of a matrix. Similarly, Ka whole power theta, K bar, it is not K power theta, please. The reason, K is a number. Conjugate transpose. It won't affect on a number because all the entries multiply with K. Transpose won't affect on K. But conjugate affect on K because K can be complex number. When K is 2 plus 3i, it is 2 minus 3. Therefore, Ka whole power theta is K bar A power. Small difference. Here K is a number. Similarly here, Ka whole inverse is K inverse A. It is right, please. You may get doubt. Sir, AB whole inverse, B inverse, A inverse, we know it, but you have written wrong. Here K is a number, please, not matrix. Its meaning, I have a given a matrix A given. I have a matrix A. I calculate its inverse. Suppose for example, A contains 1, 2, 3, 4. I calculate its inverse. Now I need the inverse of not 1, 2, 3, 4, 100, 200, 300, 400. Do you find A inverse again? Not required. Because 100, 200, 300, 400. You just take 100 common. It's not determinant, please. From all the entries, take 100 common. 100 into A. 100 into 1, 2, first row, 3, 4, second row. Its inverse is 100 inverse. 100 inverse means 1 by 100. 1 by 100 into A inverse. It's 1, 2, 3, 4 inverse matrix. Inverse of 1, 2, 3. I think got it. Here K inverse means 1 by K. When K is 100, it is K inverse is 1 by 100. It is right. Next. A plus B whole transpose. A transpose plus B transpose. Or in other words, transpose of sum of matrices is sum of transposes. In words, transpose of sum of matrices is same as sum of transposes. Similarly, A plus B conjugate of sum of matrices is sum of conjugate of matrices. Similarly, conjugate transpose you can separate it. Now it is addition. Now, similarly, A plus B whole inverse equal to A inverse plus B inverse. Okay, are you okay? Are you following or not?
Yes, sir.
Yes, okay. Do you agree with me? Do you agree with me here? Do you get any doubt? Do you get any doubt? First okay, second okay, third okay, fourth okay. Do you agree? I think you are getting doubt. I want to frame one question now itself as a gate question. In third one, it is option A, option B, option C, option D. Which of the following is false? 4 options given to you. Please tell me now, at least. Your doubt will be clear now. It is option A, option B, option C, option D. Which of the following is false? Please tell me. Rukmini, please. Among these 4, which one is wrong? ఏది రాంగ్ అనిపిస్తుంది మీకు ఈ నాలుగిట్లో?
Fourth one, sir.
D, sir.
వెరీ గుడ్. వాట్స్ యువర్ నేమ్? యోగినా ఎవరు?
Yes, sir.
Yogi, right? Very good, very good. This fourth one is wrong. Gate లో ఇలాంటివి ఇస్తారా? చూపిస్తా గేట్ బిట్స్ కూడా తర్వాత. ఫస్ట్ ఐఎమ్ ఎక్స్ప్లెయిన్ ది బేసిక్. ఇట్ ఈస్ రాంగ్, ప్లీజ్. రాంగ్ ఇది నాట్ ఈక్వల్ ఇది. I think you got it now. Okay? ఇలాంటి బిట్స్ వేస్తారు మీకు. Next one. Okay. Now AB whole transpose is P transpose A transpose. In reversal law we call it as same order rather than transpose. But repetition K into A sum next product. Of course, plus can be replaced with minus. It is also okay. Into by is not there. A by B ala ledu manaki AB whole transpose. Similarly, AB whole bar A bar B bar. It is not reversal, please. Conjugate is same order, please. A bar B. It is right. Don't write reversal. Now commit here. It is reversal again because applying both. Applying both. After this, apply this. Conjugate form. It is reversal. Now what about here? It is also reversal. B inverse A inverse. Reversal. Of course. These again I can frame a bit here. If I write B bar A bar, which one of the following is false? Means B bar A bar is wrong. I think got it now. Okay. I have explained 16 properties. Of course, here it is wrong. Next. Now, note these points. AB equal to AC implies B equal to C. Do you agree? Do you agree or not? This equation gives this equation. Do you agree or not, please?
Yes, sir.
Yes, okay. It is wrong, please. It is wrong. Which of the following is right? Which of the following is false? It is wrong. If AB equal to AC, then B equal to C statement is wrong. Why it is wrong? Let me explain. These are not numbers, please. We are in matrices. For example, I will show to you. Need not imply is right. It is implies wrong. It is need not imply. It won't give this, please. Not implies. The reason. Example. For example, A is 4 ones. And this B is 1, 2, 3, 4. P. What is AB? Row column wise you can multiply, please. 1, 1 with 1, 3. 1, 1 with 1, 3. 1 into 1 plus 1 into 3. 1 plus 3, 4. Row column wise, please. 1, 1 with 2, 4. 2 plus 4, 6. Similarly here, 1, 1. 1 plus 3. 1, 1 with 2, 4. I think you got it now. Now, A, 1, 1. And B, I have taken another matrix, please. 3, 4, 1, 2 it is. AB, this is AC. Now tell me AC. Now tell me this AC, the product of these two matrices, please. Anyone of you, please? What is the product? Please tell me the answer here. What is the answer?
4, 6, 4, 6.
Very good. 4, 6, 4, 6. Now what do you observe from it? AB, AC, both are equal, right side? AB is this one, AC is this one. AB, AC. What about B and C? Are they equal?
No, sir.
So it fails. I think you got it now. Because row column wise, it fails. These are not numbers, matrices. Therefore, AB equal to AC implies B equal to C is wrong. When it is right, do you know it? There is a condition. When it is right, if det A not equal to 0, then A inverse does not exist. A inverse is at AD minus B. Here is 1 minus 1, which is 0. Got it? Implies B equals C is right when A is invertible. Means if A inverse exists, means and determinant is not equal to determinant of A not equal to 0, then only you will get B equal to C. Okay. Next. Now observe another property. AB equal to 0 matrix implies A equal to 0 or B equal. The product of two numbers is 0. Definitely at least one number is 0. We know it. Product of two numbers is 0. At least one number is 0. Product of two matrices is 0 matrix. Then at least one matrix is 0. Do you agree? Do you agree?
No.
It is also wrong. It is also wrong. Please let me explain why. Let me explain. I remove this. I have taken one matrix A, another matrix B. Please observe. Example. Now multiply both. Here A is not a zero matrix. B is not a zero matrix. Multiply both. Now tell me the answer. Row column wise. Please tell me the answer. What is the answer here?
0, 0, 0, 0.
Right, very good. You got zero matrix. Both are non-zero, but the product is zero. Got the meaning? At least one is zero, may fail. Both are non-zero, but the product is zero. It may happen. Means product of two non-zero matrices may be a zero matrix, maybe zero matrix. That statement is right. Which of the following statement is true? You may be asked like this. 4 statements may be given. The product of two non-zero matrix may be zero matrix, which is right. Therefore, product 0 need not imply this. The next one. A plus B whole square equal to what? Please tell me. What is A plus B whole square?
A square plus B square plus 2AB.
Which is wrong. When AB are numbers, it is right. But AB are matrices, it is wrong. It is right now. Because AB, BA need not equal, we know it. Got the meaning? Got the meaning, please? Please. Are you following or not?
Yes, sir.
AB, BA need not equal to write 2AB. That's why you should not write 2AB. Next. What is A plus B into A minus B? Please tell me. I think now you can tell. AB are not numbers, matrices. Now tell me this. What is the answer? What is the answer? A square? A square?
Plus AB, sir. Minus
A
AB.
square? Next?
Plus BA minus B
Plus
square.
A, very good.
Minus B square.
Minus B square. One more term is there, AB.
Yes, sir.
A square minus AB plus BA minus B square. Because these two won't cancel. That's the point. A square minus AB plus BA plus minus B square. These two won't go. If you write plus AB minus BA, it is wrong again. Please don't write plus AB minus BA, which is wrong. You should write minus AB only plus B. Got it? Okay. But A square minus B square is wrong because these may not cancel. Now observe. If two matrices given to you, you can easily add it to get new matrix. Here, a matrix given, you are asked to write it as sum of two matrices. A matrix given, two matrices given, you can easily add it and you can give the answer. But the reverse, 2 plus 3, you can easily tell 5. Suppose 5 given, write sum of two numbers. 5 can be written as, please tell me. 5 can be written as, anyone please. How do you write 5? 5 can be written as 2 plus 3 or 1 plus 4. You have many answers. Now here, a square matrix given, you are asked to write it as sum of two matrices. But the first one should be symmetric matrix. When do you say matrix is symmetric? When do you say matrix is symmetric, please?
When A transpose equal to A.
Very good. When do you say matrix is Q symmetric?
Minus A transpose.
A transpose equal to minus A. Okay.
Minus.
A transpose equal to minus A. Now, I need this A as sum of two matrices in which the first one should be symmetric matrix. The second one should be skew symmetric. Observe. Here the matrix is A plus A transpose by 2. A plus A transpose by 2. Here the matrix is A minus A transpose by 2. Here by 2 means scalar multiplication. Now, why this is symmetric? Please observe. A equal to B plus C type. I have taken this matrix as B. It's transpose. It's transpose. So it's transpose. This 1 by 2 won't affect on transpose. A transpose plus A transpose transpose. I think you got this. It's 1 by 2 won't affect. A transpose plus A transpose transpose. Now A transpose transpose is nothing but A only. So this is same as this because A plus B is B plus A. You are getting the same matrix. A transpose is A. It looks as B transpose is B only. B transpose is B means this matrix is symmetric. Its transpose is itself. Its transpose is itself. Hence, A plus A transpose by 2 is symmetric. Now, we take A minus A transpose by 2. It is same as A plus A transpose by 2, of course. Now, I am taking this one. A equal B plus A. Now, C. I have taken C. C transpose. It is half can be written outside. A transpose minus A transpose transpose. A transpose minus A transpose transpose. Now this transpose is A only. Now this 1 by 2 you can write like this, A transpose minus. Minus I have taken common please to get this one. Take minus comma, then A minus A transpose, minus half by 2. So let us assume it is C. C transpose is minus C. It is C. C transpose is minus C means C is skew symmetric. C transpose is minus C. C is skew symmetric. So A is A plus A transpose by 2 is symmetric matrix. A minus A transpose by 2 is skew symmetric. Now if you add both, what happens? Please observe. LCM is 2 only. A plus A transpose plus A minus A transpose. What happens finally? A transpose get cancelled. 2A by 2. You get A only. So a matrix can be written as sum of two matrices in which the first one is symmetric, the second one is skew symmetric. In particular, this is called symmetric part of A. Symmetric part of A. And this is called skew symmetric part of A. Okay. Next, same concept. Every square matrix can be written as Hermitian plus skew Hermitian. When do you say matrix is Hermitian, please? When do you say matrix is Hermitian? Please answer. When do you say matrix is Hermitian?
A power theta equal to A, sir.
Very good. Skew Hermitian?
A power theta equal to minus A.
Very good. Now I have given A. Now tell me Hermitian part of A. Hermitian part of A. You can easily tell now after observing fifth one. Please tell me Hermitian part of A. It is symmetric part. What is Hermitian part of A?
A plus A power theta by 2.
Very good, very good. What is skew Hermitian part of A?
Minus A power theta by 2.
Very good. Got it. I think you got the same logic, okay? Right. Every matrix, square matrix can be written as sum of Hermitian and skew Hermitian like this. Okay. Next. Okay, so far I explained certain basic concepts. Again, I revisit some more basic concepts after certain problems given in GATE examination. Okay. Yeah, now it is 8 o'clock. Half an hour I will explain the GATE previous bits. Okay. The same syllabus is there for different branches. I selected certain bits from different branches of GATE. For example, this is a problem given for mechanical in 2016. The same syllabus is there for mechanical also, for all the branches. A real square matrix is called skew symmetric if. You can easily answer it, please tell me. Problem given in 2016. Real means real entries, square matrix, skew symmetric if. Now tell me the answer.
A transpose
A
equal
transpose equal to minus A.
Very good, very good. Direct bit it is. Directly a bit given to you. This is the answer, please. This bulb has come. Okay. Next problem. This is a problem given for civil engineering in 2014 GATE examination. Given J equal to this and K equal to this one, then product K transpose JK is dashed. Okay. You should do rough work. Okay. Directly you can't answer. You are asked K transpose JK. Okay. First I calculate JK because J and K appears directly to us. JK. JK. Now tell me JK. What is the order of J? Order of J. Please tell me order of J.
3 cross 3.
Very good. What is the order of K?
3 cross 1.
Very good. What is the order of the product JK? Product JK?
3 cross 1.
3 cross 1.
Right. 3 cross 1 means you will get 3 rows but only 1 column. Got it? 3 rows but only 1 column. Okay. Now 3 to 1 with 1 2 minus 1. What do you get? The first one. Only 1 column you will get here. 3 rows but 1 column only. 3 to 1 with 1 2 minus 1. Please tell me. 3 into 1 plus 2 into 2 plus 1 into minus 1 means 3 plus 4 minus 1. It is the first element. Now tell me the second one. 2 4 2 with 1 2 minus 1. 2
2
plus 8.
plus 8 minus 2.
Very good. Now tell me the third.
1 plus 4 minus 6.
Right, very good. You have single column, please, because 3 cross 1 it is. Of course. This is JK. Now I require K transpose with this JK. What is K transpose? Now I am writing the answer. K transpose JK. Now what is K transpose? Please tell me. Its order is 1 cross 3. You should write it as a row. K transpose. That is 1, 2 minus as a row now. It's 1 cross. What is the order of this one? It is, please, it is JK is this one. JK is this one. JK is nothing but 3 plus 4 minus 1 means it is 6. Here 2 plus 6, 8. Okay, I am writing JK. This is 6, this is 8, and this is minus 1. This is JK, calculated this. Okay. Now, what is the order of K transpose? 1 cross, 1 row. What is the order of JK? Please tell me. Order of JK.
3 cross 1.
3 cross 1.
What is the result? Result order?
1 cross
1
1.
cross 1.
Class 1. Now tell me that 1 class 1. It is a number, simply number. Tell me that.
23, sir.
Right, very good. 1 into 6 plus 2 into 8 plus minus 1 into minus, which is 20. 23 is the answer, please. Very simple bit given, please. You are asked for simply matrix multiplication. You should know what is transpose. You should maintain the order, please. Okay. Next problem. This is a problem given for civil engineering in 2017 GATE examination. The matrix P is the inverse of a matrix Q. P is the inverse of a matrix Q. If I denotes the identity matrix, which one of the following options is correct? Tell me the answer. The direct bit.
C, sir.
Very good, very good. The reason P is the inverse of a matrix Q. P and Q are inverse to each other. Their product is I. Okay. Therefore, PQ, QP both should be I, please. Both should be I. Okay. Next. The next problem given for electrical engineering in 2019. Now observe this. After seeing this problem, you may be worried about it.
Yes.
But please observe, it is very simple problem. If you concentrate, consider a 2 cross 2 matrix. The problem given in notation. Numbers appear, you will feel very comfortable, but numbers are not appearing. 2 cross 2 matrix, M equal to V1, V2. He is saying 2 cross 2, but only one row given. Don't worry. This what is V1? V1 is column vector. V2 is column vector. Please. V1 is a column vector. V2 is a column vector. V1 is a column. That column denoted with V1. V2 is a column. Yes, you can think V1 is some AB, A. Here V2 is CD type. Okay. Suppose M inverse is U1 transpose. U1 transpose is row vector. U2 transpose is row vector. These two are row vectors. Automatically it is also 2 cross 2 matrix. Consider the following statements. Statement 1. This U1 transpose V1 equal to 1. U2 transpose V2 equal to 1. This is the first statement. Statement 2. U1 transpose V2 equal to 0. U2 transpose V1 equal to 0. Among these two, which statement is true? Or both are true or both are? I think after observing the previous bits, you are very comfortable because you thought that the bits are very easy. Don't think it is difficult. It is also very easy bit because you don't have habit of writing symbols. Okay. Whenever problem given like this, you need not worry about it. What is given? M given. M inverse given. 2 cross 2 matrix. Very simple. If M and M inverse given, what can you write? What can you write? I require an equation from these two. Please tell me the equation. Matrix equation. M given, M inverse given. I want to use both, okay? You have to think like it, please. M and M inverse both given. What can you write? Tell me one equation from these two. If you know M and M inverse, what can you say?
M into M inverse equal to I.
Very good, very good. You got it. You got the answer. Definitely you'll get gate right. Okay. Good rank. Because M and M inverse both given, M inverse into M is I or M into M inverse is I. Both are right. Okay. Got it. M into M inverse or M inverse into M. You may get doubt. Sir, why you are writing M inverse first, not M first? Because U1 transpose, if you observe transposes are in the statements, the transposes are given at the beginning. Transposes, then vector. Transposes, then vector. That's why I have written this M inverse first. Of course, M into M inverse is also I. But I am using M inverse and then M. Okay. Now, simply substitute these. What is M inverse? This is M inverse. Okay. Got it? This is M inverse. What is M? V1, V2. This is 2 cross 1 matrix. Please, actually 2 cross 2, but each is row vector. This is a row vector. U1 transpose. Both are row vectors. Now, it is V1, V2. Both are column vectors, of course. Column vectors. V1, V2 column vectors. What is the order of this one? Your entry is a column. Please, your entry is column. The entry is column. It is 1 cross 2. Here, the entries are row vectors. In matrix, the entries need not be numbers. They can be vectors again. This is one vector, this is another vector. Similarly, these are row vectors, these are column vectors. So, a matrix with 2 entries here, both are row vectors. Here, column vectors. Okay. What is the result? Now tell me the result, please. What do you get result, please? The product is? What is the order of the product, please tell me?
2 by 2 matrix.
2 by 2 matrix. Very good. 2 by 2. 2 cross 2. 2 cross 2 unit matrix, please. Because the product is I. This is M minus M. That is 1, 0, 0. Got this point? Okay. Now observe it. Now the corresponding elements are equal. Okay. U1 transpose V1, which is 1. Got it? U1 transpose V1 is 1. It is this, please. Next, U1 transpose V2 is 0. U1 transpose V2 is 0. U1 transpose, this is this, please. Next, U2 transpose V1, which is, please tell me that. This 0. U2 transpose V1 is this 0. It is right. Next, U2 transpose V2, that is this 1. Okay, all the 4 are right. What is the answer then? What is the answer? Please tell me the answer. I just multiplied. You will get 2 cross 2
C,
matrix.
sir.
Option C, very good. Be comfortable now. Just I used M into M inverse is I. M inverse into M because I need first transposes. M inverse M into I, also M into M inverse is also I, of course. I think you got it. Any doubt in it? M inverse I substitute, M I substitute. The result is 2 cross 2. So it is 2 cross 2 matrix. The corresponding elements are equal. Those corresponding elements are these 4 only. But here 1, 0, of course, transpose given here. Okay, the 4 elements are same. U1 transpose V1 is this 1. U1 transpose V2 is this 0. Next, U2 transpose V1 is this 0. U2 transpose V2 is this one. Those 4. Okay, I think you got it. Okay. Fundamental question. Just M inverse M is I. Next one. This is a problem given for civil engineering in 2018. I think you are very comfortable with this because numbers given. Which one of the following matrix is singular? Please, you can easily answer it.
Option C.
Very good. Singular means? When do you say matrix is singular?
That is
Equal to
equal to 0.
Its determinant is 0 because 12 minus 12 remaining are not zeros. Okay, very simple. Next. The problem given for civil engineering in 2018 in GATE examination. For the given orthogonal matrix Q, 9 entries given, what is the inverse? Inverse of this matrix you are asked. Inverse of 2 by 2, adjoint A by det A. You know it? Q inverse is adjoint Q by det Q. You need det Q and adjoint A means you have to find 9 cofactors, transpose of cofactors. By determinant also you have to calculate. Large bit given to you. It takes a lot of time. Do you agree?
Yeah. Option.
No, it is wrong, please.
Option
Because-
C.
C, sir.
Okay. How you are getting that answer? That I require.
For orthogonal matrix, A inverse is equal to A transpose.
Very good. Very good. You got the point. Very good. Very good. You have to use this one. Very good. Q transpose is Q inverse. This we know it. Because orthogonal matrix meaning the transpose is inverse. Q transpose is Q symmetric. Q transpose minus Q symmetric. Q transpose Q inverse orthogonal. What you are asked? This is given to us. You are asked what is the inverse of the inverse is nothing but its transpose. Inverse is nothing but its transpose because ortho. What is its transpose? First row 3 by 7, 2 by 7, 6 by 7. This first row should come as first column only. 3 by 7, 2 by 7. It is here 3 by 7, 2 by 7. Just by observing first row as first column, A, B, D are not answers directly. Okay, here you need the knowledge of what is orthogonal matrix. I think you realized why I explained the words orthogonal and all those words to you. Okay, next. Now, this is a problem given for you recently, very recently, just 1 month before. 1 month could call incoming exam. February, this month only. We are in the February month only. For CSE 2002 question. Consider the following two statements with respect to the matrices A m cross n, P n cross n, m to n, n to m, C n cross n, and D n cross n again. Statement TR of AB. What is TR? It is given, of course. TR of AB equal TR of BA. TR of CD equal TR of DC. AB, BA, CD, DC. But the orders differs. TR represents the trace of a matrix. Which of the following holds? 4 answers given. Both are right, one is right, the other is wrong, or both are false. The 4 options given like this.
Both are right, sir.
How? How do you know it? I require reason, please. Because you have negative marking also. It is not as an MSET. In GATE examination, you have negative marking. Negative marks are there. I require reason, please. Okay, here M cross N, N cross M, N cross N. The orders are very familiar to you. What is the trace? What is the meaning of trace? What is the meaning of trace? Please tell me.
Sum of elements in principal diagonal matrix.
Sum of
Right,
principal.
very good. Sum of principal. Sum of simply diagonal means we always take principal diagonal, of course. Sum of diagonal. What is trace of A? What is trace of A? Please. My question itself is wrong. The reason, trace, you cannot call for the matrix A because M cross N it is not square matrix. Trace, we use the word only for square matrix. Do you agree? Trace of A has no meaning. Trace of B has no meaning. Trace of C has a meaning because square matrix. Trace of D has a meaning. But here, trace of AB, A into B, what is the order of AB? Please tell me order of AB. What is the order of A into B?
M cross
M by
N.
N.
A cross.
M cross M. So it is a square matrix. A into B is a square matrix of order M. So I can call trace. I can use trace word on AB because AB is a square matrix. What is the order of BA?
N cross N.
N to M, N to M. If N cross N it is. BA is, the left side is M cross M, right side is N cross N. The orders differs. Okay. Now coming to C and D. What is the order of CD? Order of CD? Please tell me order of CD. C N cross N, D N cross N. What is the order of CD?
N cross N.
N cross N. Order of DC?
N cross N.
Very good. Here orders same. Here orders differ. What is the now tell me the answer. Please guess the answer at least.
Option B.
Statement 1 may be wrong. Statement 2 may be right. But don't put guess answers, please. Okay. Like this, you may think, but don't put guess answers. Please let me explain how to answer such questions. Because you know the meaning of trace, you know the meaning of product, you know the meaning of order. Means you know all the words given in the problem. When you know all the words given in the problem, you can do the problem. Observe how. Okay. To save time, what we do in GATE examination is we take simple examples, simple general examples, not particular example. For example, what I am doing is MN. I am taking some 2 cross 3, 3 cross 2 type. Okay. For example, I am taking 2 cross 3 matrix A, B, C, D, E. Simple. Instead of A11, I use this 2 cross 3. Now I want to take N cross M. Another matrix. Don't take same matrix, please. Okay. P. N cross M means don't take its transpose. P, I am taking 3 cross 2 matrix. 3 cross 2, another matrix. It is 3 cross 2. Do you agree? Are you following? A, M cross N, it is N cross M. The cross entries, I have taken A, B, C, D, E, F, P, Q, R, S, T, U. Okay. Now I want to check the results. I want to check the results with my example. General entries. Okay. Now tell me what is AB? What row column wise you know it. Now what is trace of AB? Directly I am calculating, please. Sum of diagonals of the product AB. Okay. Now multiply first row of A, first row of A. Please, I am showing first row of A with yellow color. First row of A with what? Please. First row of A with first column of B. First row of A multiply with first column of B. Now tell me this. AP plus BR plus CD. Do you agree? AP plus BR plus CD. Okay. Next, please. It's not completed. Next, first row with the second column. First row with the second column. Don't write here because it is not trace. Trace means just first row with the first column plus second row with the second column, third row with the third column, like this, please. Trace sum of diagonals. First row with the first column I have written. Now I remove here second row with the second column. That only gives the diagonal element of AB. Second row with the second column. Now tell me this, please. Addition, sum of diagonals. The result is 2 cross 2, please. The result is 2 cross 2. In 2 cross 2, first element, diagonal element, another diagonal element you will get. This one. Now tell me this, please. Any one of you, please. What's that?
DQ plus ES plus FU.
Very good. DQ plus. I think you followed. It is 2 cross 2 matrix. AB is 2 cross 2. In it, the first element, diagonal element, and the last element. This is trace of AB. I am checking the first statement. Now trace of BA. Please, I remove this yellow color. Trace of BA. Okay. Now to calculate BA, BA is again, what is the order of BA? Please tell me. Now tell me the order of BA here.
3 cross 3.
3 cross 3. Therefore, I need to add 3 elements. Previously 2 elements. 3 elements. Those 3 elements are 1, 1, 2, 2, 3, 3 elements. A11, A22, A33. Now, first row of B with first column of A, please. Got it? First row of B with the first column of A. Now tell me this. Tell me the element. Please tell me the element.
AP plus DQ.
Or PA plus QD. Because I am writing starting with P. PQ with AD. BA. PA plus QD. Okay. First row of B with first column. Now second row of B, please, because trace means diagonal. Second row of B with second column of A. Okay, 2 element. Now tell me this, the second element.
RB plus SE.
Very good, RB plus SE. Okay. Now second, 2 element. Now 3 element, because 3 cross 3 matrix it is. 3 element. Now third row of B with the third column of A. What do you get?
TC plus UF.
C plus UF. Here A, B, C, D, E, F, P, Q, R, S, T, U, these are different numbers. I checked just 2 cross. Now observe the statement 1. Does it right or wrong? Just observe. Statement 1. AP, PA. These are numbers. Okay. AP, BA. Okay. Next BR. This BR. Okay. BR is here, please. CT is here. Okay. DQ is here, please. ES is here. FU UF. Okay. All are same. Got it? What about the statement 1 then?
Correct.
True or false? Statement 1. Statement 1, true or false? Please tell me, correct or wrong?
Correct, sir.
Statement 1, correct. What about statement 2? When statement 1 is correct, statement 2 should be correct because I just replace these orders are remain same. The two orders also remain same. Got the point? By similar logic, AB, BA, whatever the orders may be, orders are different. M to N, N to M, automatically trace are same. Here, in place of M, replace M with N, still it is right. I checked for M cross N. When you replace M with N, still it is right. Got the meaning? Got it? So, statement 2, right or wrong, please? Statement 2.
Correct, sir.
Both are correct. Very good. I think you read how to check with examples. Actually, we have to check with M rows and N columns. N rows, M columns. But I checked with just simply 2 cross 3, 3 cross 2. We take simple examples and we check like. Okay? I think you got it? Okay, one more problem. Find det A. Okay, I'll stop here. Okay. It's time already. It's 8:30. If you have any doubts, you can ask. I will continue my lecture in my next session. Please. Any doubts, you can ask freely, please. You can ask very simple doubt. You need not worry about it, please. I think you realize the importance of the basic concepts from the bits given in GATE examination. Very recently bit I expected. 1 month కూడా కాలేదు లాస్ట్ బిట్ చెప్పింది మొన్న గేట్ ఎగ్జామ్ ఇచ్చిన బిట్ If you have any doubts, you can ask freely, please. Feel free to ask any doubts.
Okay, thank you, sir.
Okay, thank you.
Thank you.